This is Mrs. O'Neill for AP Chemistry, Chapter 1, Section 4, Units of Measurement. In this section, you will observe the many properties that rely on the quantitative measurements involving numbers and units. So science is not always about the qualitative, what it looks like, the characteristics, how hard, how soft, things of that nature. It's also about the measurements. So we're going to use the metric system in order to convert units throughout the science course. I suggest, like always, to pause the video, fill in your blanks in your packet, and then play to hear my words. So the scientific method is just a way of solving problems. So there's usually a way of doing this in a series of steps. So usually a scientist will make an observation, then they're going to make an educated guess called the hypothesis, and then they do an experiment to test that hypothesis. And what happens is the cycle goes on and on and on and on and on. So after many cycles and a broad explanation, then sometimes there's a theory that develops because of the patterns of how those experiments turn out, the results of those experiments. And then, of course, a law is the last ultimate goal, is to make your observation turn into a law, meaning that no matter what, it will happen over and over and over again. So if we look at this, a scientist or a person will make an observation, and then they will formulate a hypothesis, they will form an experiment, and this is a cycle within itself. So depending on the results of that experiment, your observations might change, form a new hypothesis, a different experiment, and over again. Once that develops into something that's going to hold valid for many, many experiments, then a theory might be developed, a model per se. And then again, that theory is going to lead to some kind of prediction, again to an experiment, and this is also going to be modified, and then again a nice big cycle happens here. Eventually, possibly, it turns into a law. So there's many of these. There's many observations, hypothesis, experiment cycles, many. Then some of them turn into theories, and again we have less of these cycles, but they're still cycles and they still happen. And then of course you have very few laws, very few observations turn into laws. So the metric system is a way of understanding how to convert between units. And the major thing I want you to realize is that a measurement is a number and a unit. So in science class, you have always been taught, 2 plus 2 equals 4, but you want to remember in chemistry, it's going to be 2 centimeters plus 2 centimeters equals 4 centimeters. So there's always a unit attached to it. And the reason for these SI units is that they are easy to convert because they're power of 10. So if we look at length and mass, length is measured in meters, mass is measured in grams. We want to remember that the SI base unit, or the international system of units, is the kilogram for the mass. That's the weird one. Temperature, we want to remember, is the kinetic energy, and it always goes back to that energy. We talked about that before in previous PowerPoints. So what's the difference between a Celsius and a Fahrenheit scale? Well, just a quick look. Here's 0, 32. This is the freezing point at different numbers for different temperature scales. Here's the boiling point. And what happens is you take the change. How much does it change? And you can formulate what's called an equation to transfer from Celsius to Fahrenheit. Well, where does this 9/5 come in? Well, it comes from a graph. So if you were to graph the two temperatures, your boiling point and your freezing point, at 0 degrees Celsius and at 0 degrees Fahrenheit. Now, again, it's not at 0 for Fahrenheit. It was at 32 degrees for freezing. You would get this slope of 9/5. So that's where that comes from. That's where that equation comes from. Oops. So an SI derived unit is just a unit that has two or multiple units together. So we can say density is grams per milliliter. So for water, and this is something you might want to keep in the back of your head because it's going to be very useful, is that water's density is 1 gram per milliliter. So we want to remember that every time we mass out 1 gram of water, we really have 1 milliliter, or vice versa. That's going to come in handy. Volume, these are just units to remember. We want to remember that 1 milliliters equals 1 cubic centimeters. I believe that was also on your summer assignment. Same thing with liters to decimeters cubed. 1 liter equals 1 cubic decimeters. So again, keep that in the back of your head. So I will answer any questions you may have in class.